So hello and welcome guys. This is Ashutosh and this is the first class of basic electrical engineering. So let's start guys. So first of all we will study the classification of electrical networks. So guys, you can see over here the first definition is of linear network is a circuit or network whose parameters or elements like resistance, inductances, and capacitances are always constant irrespective of the change in time. Voltage, temperature, etc. is known as a linear network, guys, and the Ohm's law can be applied to such networks. You can see over here in the second slide I will give the examples. Okay, so see the second definition: non-linear network, a circuit whose parameters change their values with change in time. You can see over here time, temperature, voltage, etc. is known as non-linear network, and the Ohm's law may not be applied to such networks. This is very important point. So what happens? Such network does not follow the law of superposition, and the response of the various elements is not linear. This is very important point with respect to their excitation. And you can see in the second slide I have given some examples. You can see over here unilateral component or element. You can see here, okay, unilateral element conduction of current in one direction is termed as unilateral. Examples are diode, transistor, and all the semi-conducting devices. So guys, these are non-linear network. Okay, these are the examples of non-linear network. Like you can see over here, the diode conducts in forward bias. It does not conduct current in reverse bias. As you can see over here, this is the forward bias, and current will flow like this from left to right. But in reverse bias diode, current cannot flow. Okay, and what is bilateral element? You can see from here bilateral elements: conduction of current in both directions in an element. Example: resistances, inductances, and capacitances. Also these are called linear components, okay, with same magnitude, is termed as bilateral elements. So you can see over here resistances, inductances, and capacitances, okay, are termed as a bilateral element. So these are also called linear elements, as you can see over here in the first slide. Okay, linear, a circuit or network whose parameter or elements like resistances, inductances, and capacitances are considered as a linear network. This is very important point. So just moving on to third slide, as you can see from here, this is the VI characteristics shown over here. This is the VI characteristics of a resistor. You can see this is the first one. This is linear, almost linear. Okay, this is the inductance characteristics, then capacitance characteristics. Okay, so these are almost linear, and practically there will be a tilt, okay, in a bulb, or when you perform VI characteristics of an incandescent bulb, then there will be a some tilt in the VI graph. Okay, but almost it is a linear graph. And but you can see over here, this is the VI characteristics of triac or diac, and this is the VI characteristics of a practical diode, and this is the ideal diode. You can see over here. So these are non-linear VI characteristics. Okay, so moving on to the next slide. So guys, as you can see from here, what are the active elements? So a circuit, you can define a circuit which contains at least one source of energy is called active element, and an energy source may be a voltage source or current source. As you can see over here, this is the DC circuit, or it is also called active network, because the DC voltage source is connected over here, okay, and DC current source is also connected over here in the circuit, as you can see. So what is the active element? Those elements which provide electrical energy to the elements like resistances, inductances, capacitances. Okay, so these are the source of EMF, and these provide electrical energy. That's why these are called active component. And what is the function of passive component or passive network? You can see from here, the passive network, a circuit which contains no energy source, is called passive elements, like resistors. So guys, these are the elements which receive electrical energy, like these resistances consume electrical energy. These are the resistances, okay, and there is no energy source. Also from here you can see active elements, examples of active elements. You can see battery, generator, transistor, tunnel diode, triode, and semiconductor devices are also considered as active elements. And passive elements, the examples of passive elements are resistor, capacitor, inductor, transformer. Okay, so these are the basically passive elements. Okay, then moving on to the next slide. Okay, so see here, what is lumped network? So guys, a network in which all the network elements are physically separable is known as lumped network. Most of the electrical networks are lumped in nature, which consists element like resistor, inductor, capacitor, voltage source. So guys, if these are detachable from the circuit, okay, if a bulb can be detachable, inductor choke coil is connected in the circuit, and you can detach it easily from the circuit. Capacitor is connected, you can detach it from the circuit. So these will be called lumped parameter, lumped components. And distributed parameter, so guys, a network in which the circuit elements like resistance, inductance cannot be physically separable for analysis purposes is called distributed network. Okay, these are the components which are distributed along the transmission line. The best example you can see over here, the best example of such a network is a transmission line, where resistances, inductances, capacitances are distributed along the transmission line, along its length, you can see over here, and cannot be shown as a separate elements anywhere in the circuit. So you can see over here, lumped circuit, resistor, capacitor, inductor, independent and dependent sources are lumped circuit elements. Okay, and these are physically separable. And distributed circuit, in a distributed circuit, for example, in a transmission line circuit, the size of the transmission line may be a considerable fraction of a wavelength, many wavelengths. Thus a transmission line can't be modeled as a lumped circuit element, so it is distributed element, and it should be modeled as a distributed parameter network, where voltages and currents are functions of positions as well as time. So as you can see over here, so guys, you have already seen the definition. These are the parameter: linear circuit, non-linear circuit. Then we will move ahead. And what is node, branch, loop, and mesh? So guys, node is a junction in a circuit where two or more circuit elements are connected. We will see the example. Okay, what is branch? Branch is the part of a network which lies between two junctions. Loop is a closed path in a circuit in which no element or node is encountered more than once. And mesh, it is a loop that contains no other loop within it. So you can see from here, these are the example. So guys, from here you can see this is the DC circuit, and you can see here these are the nodes. This is the node, because two or three branches are connected at this. This is the common point. Two or three branches are connected here. Okay, this is also node, and these are also node because two or more branches are connected over here. So this will be called node or a meeting point. And loop is any closed path in the circuit. Loop, okay, loop can contain another loop inside. Okay, but mesh cannot contain. This is a mesh. You can see this is a mesh, single mesh. Okay, so mesh cannot contain any loop within it. Okay, as you can see over here, a mesh is a loop which does not contain any other loop within it. So this is the term which will come, okay, the mesh analysis, okay, not the loop analysis. We will call it mesh analysis. So moving ahead. Okay, now comes the voltage source. So guys, ideal voltage source and practical voltage source, two types of voltage sources are there. So what happens? This is the ideal voltage source. Okay, in the circle, the voltage source, okay, drawn like this. Okay, the voltage source is defined as the energy source which gives constant voltage across its terminals irrespective of the current drawn through its terminals. As you can see over here, this is the voltage source and this is the load. So source and load both are connected in the circuit. So it forms a circuit, and this is the symbol. You can see over here, this is the ideal DC voltage source. Plus minus electrodes are there. So if load is connected and it is drawing current from here, okay, it is drawing current from here. So even if the voltage of voltage source is maintained constant, as you can see over here, the voltage is constant, Vs is constant, it is not dropping. Okay, even if the current is drawing from here, from the source. So this will be called, this will be termed as ideal voltage source. And what will be the practical voltage source? When voltage drops, okay, the voltage is falling, you can see this is the practical voltage source. Okay, with the increase of current, load current, okay, there is a resistance connected. So this is the internal resistance. Okay, so here internal resistance is 0, and here there will be some internal resistance. So there will be a drop in voltage. So this will be called as a practical voltage source. So you can see over here, time variant sources like AC alternating sources are called time variant sources. The sources in which voltage is varying with the time are known as time variant voltage sources or AC sources. And DC sources, the sources in which voltage is not varying with time are known as time invariant voltage sources or DC sources. So these are denoted by capital letters. Okay, so this is DC voltage source because the magnitude, okay, is constant. It is not changing with respect to time. Also direction is constant. But here in case of AC voltage source, the magnitude and direction both are changing with respect to time. Okay, so the same case with the current source. You can see from here, this is the DC current source. Okay, you can see over here, and load is connected. This is the load and current is drawn from this current source, and even if the level of current is maintained, so it will be termed as ideal current source. And practical current source, so here there will be an internal resistance in parallel. Okay, so what is happening? The current is dropping from its level. Okay, so it is called practical current source. And time invariant, again, the sources in which current is not varying with time are known as time invariant. So the magnitude will be constant, direction will be constant. So these will be called DC sources, DC current source. Okay, this is the DC current source. And time variant sources means AC sources. So the sources which are, okay, discussed above means the magnitude and directions are constantly changing with respect to time, continuously changing. So that will be considered as a time variant sources or AC source. So now you can see over here the dependent sources are diamond shaped. Okay, you notice over here. Okay, so first dependent source is called voltage dependent voltage source. This is the first dependent source. Okay, so it is the diamond shape. The shape is of diamond and it is depending upon some factor which is kV1. Okay, so it is depending upon voltage. So it will be called voltage dependent voltage source. It produces a voltage as a function of voltages elsewhere in the given circuit. So this is called VDVS. Second one, you can see over here, current dependent current source. This is the current dependent current source. It is also of diamond shape. Okay, and the factor is depending upon KI1. So it will be called current dependent current source. Okay. Third one is current dependent voltage source. Current dependent voltage, so this is the third one. Okay, current dependent voltage source. And fourth one, voltage dependent current source. So these are the factors on which the values are dependent. Okay. Okay. Now you can see over here, what is Ohm's law? This is the question, okay, often asked in very interviews and vivas. So basically guys, this is the conductor or resistor. This is the resistor and potential difference V is created across this. So what is the definition of Ohm's law? The current flowing through the electric circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit provided. Okay, and physical conditions